In this question, we've been given a sample of sulfur. We've been given the mass spectrum of this sample, and we've been asked to calculate the relative atomic mass of the sulfur in the sample. And we've been asked to give our answer if it does have decimals to 2 decimal places. Okay, so to approach this question, the first thing I'm looking at is the relative isotopic masses and working to match that with what we see in the actual mass spectrum. So here we have sulfur 32. Now for this isotope, what does it correspond to on the mass spectrum? So we're looking here at the x-axis, the mass charge ratio, the MZ, and we see under 32 we've got a peak here, and we've got a relative abundance listed as 59, right? So that corresponds to the S32, right? Then if we look now at the next one, sulfur 33, and we look at the graph again, we've got at 33 we've got another peak, and we've got a corresponding relative abundance here of 50. And then for sulfur 34, we look again at the mass spectrum, we see at 34 we've got another peak, and we've got a corresponding number 49. Now in this particular case, what I'm actually going to do, and you can have a go at what you think is next, but what I'm going to do is now take the relative isotopic masses and multiply each with their corresponding relative abundances, and then I'm going to sum that I'm going to sum each of those. So let's go through that process. I'm going to just color code this for clarity. So what we've got here, first of all, looking at the sulfur 32, we've got 32, right, times 59. Then we need to add that to the next one. So it's sulfur 33. So we're going to do 33 multiplied by 50. Right, and then we've got sulfur 34. So we're going to do it's going to be 34 multiplied by 49, right? Following on from this, if you take some time to actually try and work that out for yourself, what that is, what you should come to is 5204, right? 5204. Now, from this point, we have to ask ourselves, well, what is the next step? Do we multiply this 52, well, do we divide this 5204 by 100? If so, why? If not, why not, right? Now, I invite you to have a think about that. Now, in this case, we are not gonna divide it by 100, but let's figure out why, right? So if we add up the relative abundances, which is the next step, and it's very important to check this, right? So if we add up the relative abundances, it's just going to be 59 plus 50 plus 49. Now it's quite obvious, just even based on inspection, that this is not going to add up to 100. and it's not going to even add up to something less than 100. In this case, it actually adds up to something greater than 100. It adds up to 158, right? So this is one of the reasons why when you've got these values, it's very important to check. You shouldn't just assume, okay, well, I'm going to just add up the sum of the relative isotopic masses multiplied by the relative abundance and just divide it by 100, right? So in this case, we would actually have to divide 5204 by 158, right? So 5204 divided by 158. Right, so I'd invite you to have a go at working out what that is. And if you did have a go, what you should get is that is equal to 32.936709 basically. And then the question is, well, is this actually our answer, right? Now, the question gives us a very specific requirement. It says we need to give our answer to 2 decimal places. It's always important to pay attention to this. This is obviously not to 2 decimal places yet. So what we're going to do at this stage is we're going to round this up. So what we do is that it's going to be equal to 32.9. Then based on the 6, we're going to just round it up to a 4, okay? 32.94. And so is this our answer? 32.94. Yes, in this case, this would be our answer. This would be the relative atomic mass of the given sample of sulfur in this case. And one of the things you should observe from this particular example is that, as you can see, the relative abundance, when we added it up, it came to a total that was not 100. It's greater than 100, but there's not actually a need to be too concerned. All we really needed to do was just make sure we actually got what number it added up to and factor that into our calculations. And as part of this, as far as we've kind of established that this is the answer, but we could also just do a quick sanity check again, as just a general, well, what range should we expect our answer to be between? So the isotopes we were given in the question, 32, 33, 34, right? That kind of effectively establishes a clear range of what would be an acceptable answer in this case. So it would be something between 32 and 34. So we could say that our answer A, which we already have established that A is 32.94, but based on the actual question itself, we can say that A should be greater than or equal to 32, and it should be less than or equal to 34, right? Although it would not actually be, usually one of those 32 or 34, unless, for example, if the relative abundance of the sulfur 32 was 100%, or if the relative abundance of the sulfur 34 was 100%. But this does give us a quite useful sanity check for evaluating, well, does our answer, just based on the question, seem sensible? And that can help to safeguard against calculation errors. Okay,